Either is that guy. Please say my presentation is visible.
सर तुमचा आवाज येत नाही.
Hello.
हा येस सर विजिबल.
Okay. Audible? Hello. Hello.
Yes, sir.
Hello. Okay. So very good morning to all. So as in my previous lecture, we have discussed about the first mechanical energy based process, that is abrasive jet machining. Then we have discussed the water jet machining. Okay, all the points: working principle, mechanism of material removal, then what are the elements, or I will say the setup of that both the machineries, both the processes, and then we have gone for the parametric analysis. That means the process parameters, or what will the effect of different process parameters on the output response. That means the accuracy, material removal rate, okay, and application. So as we have covered this AJ and W. So now will discuss the similarities between these two processes and what are the differences between these two processes. Okay. So before that, difference or similarity, I will just quickly will go through the basic also. So with mechanical energy based on non-traditional machining processes or non-conventional machining processes, they are directly utilizes mechanical energy for what purpose? To gradually remove the material from where? From the workpiece. Okay, and that action or that material removal action is due to by or due to only erosion. Okay, so what are the examples of mechanical energy based processes? We know abrasive jet machining, water jet machining, abrasive water jet machining. That today we are going to see, and the fourth one is the ultrasonic machining. Okay, now if you talk about the in abrasive jet machining, okay, if you talk about the abrasive jet machining, here also I have shown the diagram of abrasive jet machining setup. So in this abrasive jet machining, abrasive particles, okay, abrasive particles are are first mixed with the a compressed gas, correct? That may be the carrier gas, or it may be inert gas or air. Okay, so that mixing will happen at a predefined mixing ratio, and this mixture is then directly goes toward the workpiece in the form of high velocity abrasive jet. Correct? Here you can see, and by this nozzle you extract this high pressure, high velocity jet on the workpiece. So here the small diameter of nozzle you will there, and that small diameter of nozzle will convert the pressure energy of the air abrasive particle. I will repeat: pressure energy of air abrasive mixture into the kinetic exiting from the nozzle. That kinetic jet, that means the high velocity jet you will get, and when it will strike the workpiece, then this high velocity jet, it will erode the material from the erode means what? Erosion action. So due to that, high velocity jet erodes material from this workpiece at a controlled rate. Okay, at a controlled rate. That means up to desired shape or size whatever you want on the workpiece, and due to that, material removal will happen. Now here, one basic thing is that nozzle will maintain the appropriate this stand-up distance or charge angle also. It is the distance between your tip of nozzle and top surface of jet. Okay, so here material removal will happen due to the kinetic energy of high jet abrasive jet. Okay, that erosion, kinetic energy and action of material removal will erosion. Okay, so here participation of abrasive particle, okay, for the as well as the role. Okay, now talk about the, just I have taken the overview of the abrasive jet machining. Same here I have shown the diagram. Already we have discussed. Now if we talk about the water jet machining, okay, we have discussed in the last lecture also. So in water jet machining or WJM, a high velocity jet of water, high velocity jet of water is used for what purpose? To remove the material. And here fluid pump, okay, here I have shown fluid pump is used to increase the water pressure. Okay, to increase the water pressure as high as 2500 to 4000 bar. Okay, and to increase that pressure of water, we require the intensifier, or it is also called booster. Okay, so this pressurized water is then discharged with the help of small diameter nozzle, and this nozzle will convert the pressure energy. Okay, this nozzle will convert the pressure energy into the kinetic energy, and the that comes out of the nozzle, it will possess enough energy for what purpose? To slice this polymeric or organic material or the workpiece material. Okay, so thus this water jet machining is commonly used, okay, for industries. Okay, in last lecture we have seen the different applications also, and in this difference also we'll see that. Okay, so this is about the just a overview. Correct. Now for the similarity in this and what the thing is that AJ and WJM are the processes. However, none of them is both are not processes. Okay, the combination of two or more than two advanced machining processes. Here we are not going for the any combination. So this is non-traditional machining process. Both machining are the this is kinetic for and that is the process or the
सर
hello, hello,
सर तुमचा आवाज येत नाहीये.
hello, hello,
सर आवाज मध्ये
आता
मध्ये
येते का? मला लागलाय का आवाज?
हा मध्ये मध्ये स्टक होतोय.
ब्रेक. अरे नेटवर्कचा एक मिनिट हा. मी जरा थोडं बाहेर येतोय ना, एकच मिनिट. हा आता येतोय का? हॅलो
हा सर ओके.
हॅलो. ओके मी आता बरं ओके एकच मिनिट. Okay, once again I will repeat the similarities. Okay, because due to the breakage of voice I will repeat. Now first similarity between this abrasive jet and water jet machining is that both the processes are non-traditional machining processes, and both are using are utilizes mechanical energy. Okay, in that again they are utilizing directly kinetic energy for what purpose? To remove the material. Correct. आला ऐकू येते का?
Ah, yes.
हा येस सर.
हा okay. And the third similarity between these two abrasive jet machining and water jet machining is that both the process require appropriate nozzle. Okay, both the process require appropriate nozzle. ओके, आपण बघितलं की दोन्ही प्रोसेस मध्ये नोझलची गरज आहे. फॉर व्हॉट पर्पज? टू कन्वर्ट द प्रेशर एनर्जी ऑफ दॅट जेट. इट मे बी द वॉटर जेट और इट मे बी abrasive jet. Okay, to convert the pressure energy of that fluid into the kinetic energy. Okay, this is third similarity. The fourth similarity between this is the performance of abrasive jet machining or water jet machining. It does not depend on the electrical and thermal property, thermal conductivity, electric conductivity, thermal conductivity. Okay, so both performance of both the process are not depend on this electrical and thermal conductivity, as well as chemical inertness of the workpiece. Okay, so chemical properties of the workpiece also does not matter for this both the process. Then fifth one is that none of these processes, that means AGM and water jet machining, is associated with the burr formation. Okay, none of these processes associated with the burr formation, thermal damages. Okay, and the last one is similar is that both the process can be integrated. Both the processes can be integrated with the CNC system for efficient control and precise jet of precise delivery of the jet. Okay, so you can go for the automation. Okay, that is a CNC, numerical control system. Okay, for both the process you can use that, and already this type of numerical system they are using for in industry for abrasive jet machining as well as water jet machining in industry. Okay, already it is available. Okay, हॅलो, प्लीज अनम्यूट कोणी करू नका. जर काय प्रॉब्लेम असेल तर अनम्यूट करा, काय प्रॉब्लेम. ओके, हा, शॅल वी प्रोसीड फॉर द differences?
Yes, sir.
Okay, now here in this slide I have made the two columns. In first column you will get the points about the abrasive jet machining, and in the second column you will get the point regarding the water jet machining. Okay, so the first point about the water jet machining is that a high velocity jet of air and abrasive mixture is utilized for the material removal. Okay, just I have explained. Mixture of air as a carrier gas and abrasive is utilized for the material removal purpose in case of AGM. In case of water jet machining, a high velocity jet of pure water. Here we have used pure water. Okay, so that to make the pure water we are using that filter and dryer. Dryer, and that pure water, high velocity pure water, is utilized for the material removal. Okay, now the second point, in case of abrasive jet machining, working medium is dust free and dehumidified air. Okay, working medium is dust free and dehumidified air. In case of abrasive water jet machining, working medium is clean water. Okay, now third point about AGM is that air compressor is used, okay, to deliver the or to compress the or to increase or to boost the pressure of air. Okay, because here we are used for carrier gas. Okay, as a carrier gas in case of AGM. So to boost the pressure or to make the pressurized air, we require the air compressor. Now in case of water jet machining, in place of air compressor, liquid pump along with intensifier is used to deliver the pressurized water. Okay, the next point about the abrasive jet machining is that air pressure is typically remains between 2 to 10 bar. Okay, but in case of water jet machining, water pressure remains very high, and it is typically in between 2500 to 4000 bar. Okay, now again here I will clear that this statistic 2 to 10 bar or 2500 to 4000 bar, again it varies depending upon the workpiece as well as the your machining action. Okay, so for every research paper you will get this different. This is not ideal, but near about this. Now next point about the water jet machining. Velocity of the air abrasive mixture jet when it comes out of the nozzle usually remains in order of 100 to 300 meter per second. Okay, already we have seen that also. The velocity of high jet air abrasive jet mixture is around 100 to 300 meter per second. But in case of water jet machine, velocity that water jet when it comes out of the nozzle, it remains around 900 meter per second, or it remain or around 1000 meter per second. Okay, in many book as well as in many research paper, they have mentioned 900 meter per second for water jet machining. Then average in case of average jet machining, there always exists a tendency of glit embedment. Glit means what? Small particles, okay, or grain sized particles. Okay, so glit embedment on the machine surface in AJM. Okay, embedment is what? There will that glit or grain size of small particle will stick on that machine surface. Okay, in case of average jet machining. So due to that, this may affect the surface property as well as the appearance of that finished surface. Okay. But in case of water jet machining, it is not associated with the any risk of any embedment because there is no abrasives are utilized for here. Okay. abrasive आपण कुठं वापरतोय तर एजीएम मध्ये. सो तिथं त्या abrasive स्मॉल ग्रेन साईजचे पार्टिकल आहेत किंवा ग्लिट म्हणतो आपण त्याला, ते तिथे चिटकू शकतात की ऑन दॅट मशीन सरफेस. पण इथं वॉटर जेट मशीन चिटकणार आहे का, तर तिथं मी abrasive पार्टिकल वापरत नाही. ओके, सो दॅट इज अ सिम्पल मिनिंग. देन abrasive jet machining cannot be employed in food processing industries. Okay, why? Because due to inherent risk of abrasive contamination. Already this point I have discussed during the discussion on this that fishbone diagram. Okay, abrasive particle असल्यामुळे आपण abrasive jet machine आपण साठी आपण वापरू शकणार नाही. ओके, कारण की abrasive particle पण आपण वॉटर इंडस्ट्रीला काय प्रॉब्लेम आहे ना, आपण ते स्लायसिंग इंडस्ट्रीमध्ये वापरू शकतो, काय स्लाइस वापरू शकतो कट करा. Okay, they have because here this material I report from the one book, so they have given the general application, not in terms of that machining. Okay, but same part that machining we discussed during that lecture also. Okay, one minute. I should. Machine
आवाज
येतोय. हॅलो,
अडकतोय
येतोय.
खूप.
अच्छा, फास्ट बोलल्यानंतर काय. ओके, efficient machine case of we talk about the machine, what does not so this warning is okay. So this is these are points in the what
आवाज ब्रेक होतो तुमचा.
सर वॉइस ब्रेक होते सर.
हॅलो नाव
हा सर. हा हा हा. नाही येत सर. अडकतोय.
नाही 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 सर, येत नाही आवाज.
वाची नाही. हा जॉईन झालोय. हा आवाज येतोय का रे? अथर्व आता येतोय का?
हो सर.
हा येतोय सर, आवाज
कसं
येतोय.
थोडं इंटरनेटचा प्रॉब्लेम आहे बरं का, थोडं समजून घ्या. जरी वाईट ब्रेक झाला तर तो पॉईंट मला सांगा, रिपीट करतो बरं का.
हो, हो.
ओके, वाईट ब्रेक झाला लगेच मला सांगा कोणी तर. ओके, सो आय विल स्टार्ट प्रेझेंट वन्स अगेन. Okay, now whether my slide is visible to you all?
सर.
Yes sir,
Okay,
visible.
now while writing the difference in an exam, first you have to write the technical points for which energy is used. Okay, then material removal action. What will the action of material? Okay, the components are used. Then what pressure? That means what will the statistic about the pressure? What will the that mixture velocity in statistics? In mathematically you have to write. Okay, then you can go for the general point. Okay, that application point should be at last. Okay, so here I have given the sequence also. Okay, understood?
Yes sir.
Understood?
Yes sir.
Yes sir.
Okay, बरं तुम्ही लिहून घेता का हे का नको? जायचं पुढच्या पॉईंटला. Because I will share the PPT, no problem.
Okay sir.
Yes sir, yes sir.
Oh, okay. We'll go for the new point now. Okay.
Okay.
Now we have covered the average jet machining and water jet machining. Now we'll go for the new process which is belongs to the water jet machining. Sorry, mechanical energy based process that is called jet machining. First we learn about average jet machining. आता काय आणि पुन्हा वॉटर जेट मस्टिंग. आता मी काय करतो दोघांचं कॉम्बिनेशन करून नवीन मेथड शिकलोय घेतोय. ओके, ॲव्हरेज वॉटर जेट मस्टिंग. बिफोर गोइंग टू वर्किंग प्रिन्सिपल ऑफ ॲव्हरेज वॉटर जेट मस्टिंग, I want to highlight about the applications of the averages for the various machining. ॲव्हरेजेसचा मी कुठं कुठं उपयोग करू शकतो मशीनीमध्ये, कुठल्या कुठल्या मशीनीला. त्याच्यावर मी थोडा हायलाइट करतो आणि देन विल गो फॉर द working principle of this machining. Okay, so again, so in go for the material removal mechanism or working principle of water jet machining process. Sorry, average water jet machining solution and application, and then we'll go for the setup. Okay, so firstly I will start with the applications of abrasives. Applications of the abrasives in machining. Why I am taking this part? Because if you know the drawback of abrasive machining or other process where abrasives are used, okay, or from that drawback you will get the some improvement point. Okay, our researcher already they have gone for the improvement, and from that improvement they have developed a new method, a new process that is called abrasive water jet machining. Okay, so you should know the background. For that purpose I am taking this point. Okay, now so here I am trying to show you that various processes which are based on abrasives, or I can say where you are using the abrasives, okay, for cutting or machining purpose. Okay, for cutting or machining process. So if you see the on the left hand side here, okay, at the left hand side you can see that traditional machining processes which are based on the applications of the abrasives. These are the traditional machining processes where we are using the abrasives. Okay. Now they are grinding, honing, lapping, surface, finish, and similar other processes. Okay. Now, so here one of the point to note over here is that these all processes are applicable. These all processes are applicable for electrical conductive material as well as electrical non-conductive metals. Okay, and if you talk about the advanced machining processes, here one side I have given the traditional machining processes where we are using abrasives. Now at other hand here in advanced machining processes, like so which are based on the applications of abrasives, they are that advanced machining processes are means abrasive jet machining and ultrasonic machining. Okay, for both the processes, abrasive jet machining and abrasive and water jet ultrasonic machining, we are using abrasive particles. Okay, so already I have discussed the AGM, that is abrasive jet machining, and this ultrasonic machining we will cover in next lecture. Okay, so if you talk about the this AGM, here carrier gas is used, okay, which is carrying or moving the abrasive particles, okay, in and that carrier gas is the air, okay, and which is easily available, that is also cheap. Okay, that air is cheap, easily available and non-toxic. So we are using carrier gas as a air in case of abrasive jet machining. What is the purpose of carrier gas? To move or to carry the abrasive particles. Okay, and so I can say air is driver for the abrasive jet. When go for the improvement. So there are various venues of improving this agent process that we will discuss in the next slide also. Okay. So due to this drawback, we have to go for the improvement. Okay. And from that improvement, we got the abrasive water jet musting. Now, this is one process where we have used the abrasive. Now come to the another side. Second is the ultrasonic musting, UVSM. Okay. So in ultrasonic machining, again you can see this ultrasonic machining, which is also based on the applications of abrasives in cutting or machining of the various advanced machining, advanced engineering metals. Okay, for the cutting or machining advanced engineering metal, we require the this process. Okay, here in case of USA, carrier medium is liquid. Okay, so carrier medium is liquid is used and abrasives are mixed in this liquid. Okay, लिक्विड मध्ये मी काय करतोय abrasives मिक्स करतोय. Okay, in case of USA. Okay, and that carrier or liquid, it is normally used as a water. So in that water we have to mix the abrasive, and that water mixed with the abrasive, water plus abrasive, it is known as liquid slurry or हॅलो हॅलो.
हाँ सर.
हाँ यस सर.
अरे नेटवर्क मुळे प्रॉब्लेम आला जॉईनच होणार रे. हे स्क्रीन शेअर केल्यानंतर जास्त नेट युटिलाइज होतंय का, असं वगैरे काय असतं का?
हो सर, जास्त नेट हे होतं युटिलाइज केल्यावर स्क्रीन शेअर.
असं बोलल्यानंतर वॉइस व्यवस्थित आहे. ओके ओके. One minute. I'll share my slide. 1 minute only. Now whether my screen is visible?
Yes sir.
Okay. So once again I repeat. Okay. In Marathi I will quickly I will take. So I was talking about the applications of abrasives. Okay, abrasives, applications of abrasive in machining. So and the machining processes which where we are using abrasive. So there we can cut or we can go for the machining of conductive, electric conductive material as well as non-conductive material. And if you take the example of traditional machining processes, grinding, honing, lapping, surface finishing, or other same kind of machinery where we can use the abrasive. Okay, and if you take the another, but okay, if you take the another side of that applications of abrasive in machine, that is advanced machining. So in that advanced again abrasive jet machining process where we are using abrasives. Now in case of abrasive jet machining, to carry or to move the abrasives, we require the carrier gas. Okay, and that carrier gas we are using as a here as carrier gas we are using. Okay, but in our average mistake we are getting low efficiency as well as low MRR, low accuracy. So to overcome this limitation or to overcome this drawback, we have to go for improvement. Okay, so that improvement means what? Our new process, that is abrasive water jet machining. This is one process. Now second process, ultrasonic machining. Okay, again here carrier gas is used, and that carrier gas is a liquid form, and liquid means what? Normally water is used as a carrier gas, and there will be the abrasives, okay, which will mix with the water, and that mixture of water plus abrasive, it is called abrasive slurry. Okay, in case of this USM only abrasive slurry is used, and in case of this USM there will be the one tool, and that tool will longitudinally vibrate with the ultrasonic frequency. Okay, but for this ultrasonic machining also we will get low MRR, material removal rate, will get the low as compared to other advanced machining process. Okay, as compared to another advanced machining processes, as well as will get the low efficiency. Okay, so here also we need some improvements. Okay, in this particular process to develop a new process. Okay, we need some improvement for what purpose? To develop a new process specifically. Okay, specifically the process which are used for the finishing purposes. Okay, so there we need the abrasive, or there we need a improvement. Okay, now you can see here in the left side, here we have gone for the improvement in the abrasive jet machining. Here we have gone for the improvement in the abrasive jet machining. Okay, and after that improvement in that AGM process, we got a result. Okay, or I can say as a result of improvement, we got a new process. It is known as AWJM, abrasive water jet machining. Okay, okay, and for this new method, we have many advantages as compared to specifically AGM. Okay, as compared to AGM, we have many advantages for this abrasive water jet machining process. Okay, so what are the advantages of this AWGM process? So this process, or there is no dust in the environment. That is first advantage. Then second is high cutting speed. Okay, high cutting speed. Then, as I have just mentioned, no dust means what? There will not be environmental pollution. Okay, so if you compare with the AGM, abrasive machining, this process has the high cutting speed. Then there are no thermal traces developed in this machine the workpiece. Okay, thermal traces will not be developed on the machine the surface because first thing is that whole workpiece. Okay, in case of AWJM, whole workpiece is completely in contact with the water. Okay, for the machining process. So thermal process will not be there, and also forces are comparatively in the localized area only. Okay, again, new advantage or more next advantage is that there is no delamination when you are machining the composite material. Okay, using this machining process, if you go for the machining of the composite material, then there will not be any delamination. Okay, if you take the example of glass reinforced plastic, okay, glass fiber reinforced plastic, then there will not be any delamination. Okay, so again, there is no fire hazardous. Then we are getting low level power requirement, as well as the quality of the cut edges. The quality of cut edges is good as compared to other. So these are the advantages of abrasive water jet machining process. Okay, now, okay, this is the improvement in the abrasive jet machining, and we got the AWJM. Now, if you take the finishing process, okay, finishing process means what? Abrasive flow machining. You can see here also abrasive flow machining or abrasive process. Okay, in process, viscoelastic material is used. Viscoelastic material is used as a carrier medium. Okay, as a carrier medium. And this viscoelastic material will act as a self-deformable stone. Okay, and which will this process I am going to discuss later on. Okay, okay. So now in this particular case, abrasive flow machining or abrasive flow finishing, there is no ultrasonic vibration. Okay, there is no ultrasonic vibration as as like as in case of USM there is a ultrasonic vibration. Okay, so it uses normally hydraulic power. This abrasive flow finishing, it uses the hydraulic power unit for applying the force. Sometimes we can also use pneumatic power, okay, for giving the sufficient force. For what purpose? For the movement of the piston, so that it pushes the medium inside the working piston. So these are the improvement of the processes where we are using the abrasive, and through that improvement we got the we develop, the researcher or the people from the manufacturing sector, they have developed this new process, that is a abrasive water jet process. Got it? This is just a background, understood?
Yes, sir.
Okay, now come to the our main objective, that is the what is the working principle or what is the mechanism of material removal for this abrasive water jet machining. Okay, once again I will give example. In first lecture I have given, आपला पाण्याचा नळ आहे किंवा पाण्याचा नळ कशाला, पाऊस पडतोय, पावसाच्या पाण्यामध्ये धरून चाला की आपलं जे हे जे आहेत दगडाचं खड, ओके, सँड पार्टिकल, हे जर मिक्स झालं आणि ते जर एका कुठल्या धरून चाला की परसे आपले, ओके, सिंपल एक्झाम्पल देतो, परशी जर कंटिन्युअसली तिचं पाणी एका पाईपातून पडत असेल तर काय होणार आहे, थोड्या वेळानं तिथं तिथं थोडं लहान लहान पार्टिकल दिसते बाजून निघाले, म्हणजे काय रिमूव्ह झालेलं. तसं कंटिन्यू जर अजून ठेवलं तर तिथं मे तिथं खोल पडतं किंवा कॅव्हिटी तयार होते. ह्यालाच म्हणायचा ऍब्रेसिव्ह वॉटर जेट मशीनिंग. ओके, म्हणजे कसं नाही होतं अगेन, कायनेटिक एनर्जी ऑफ दॅट jet it is used, and due to the erosion or erosion only, that material will happen from the surface working principle. Okay, now we'll discuss the working principle. Now see here, here is the diagram of nozzle. Okay, here is the diagram of nozzle, okay, which is used for the water jet, abrasive water jet machining. Okay, see here. So in this schematic diagram, I have shown the abrasive water jet cutting system or machining system. Okay, normally this process is used for the cutting. So sometimes it is also known as abrasive water jet cutting system. So here you can see there is a high water, a high power water tube here at the top. High water, okay, high water, sorry, high power water tube, and through this tube water at very high pressure is supplied. Here I have shown also. Okay, you can see high pressure water is supplied from the high power water tube. Okay, and then on this side you can see here in the port is there. On this side we have the abrasive port through which abrasive particles are supplied. Okay, so वरनं काय येतं आपल्याला, हाय प्रेशर वॉटर, आणि तुला खाली काय एक पोर्ट आहे, तिथून abrasive particles सप्लाय होत आहेत. And then these abrasive particles, okay, but I want to clear that these abrasive particles may be the alumina Al2O3 or silicon carbide SiC or some other abrasive particles also we can use for this process. And then here we have the orifice here. That means that in this I will show the high pressure water now. At that in we have the orifice through which water jet is coming, okay, at a very high speed, at a very high velocity also. And as we can see here, the velocity of water jet can be as high as, it may be the 800 to 900 meters per second. Velocity of water jet is as high as that is 800 to 900 meters per second. Again, it is depending upon what pressure is used. Okay. Yeah. Now then we have the mixing tube over here. So we have the mixing chamber, and after that mixing tube. So in that mixing chamber, mixing of abrasive and water jet will happen. Then through that mixing tube. You can see here mixture of abrasive and water will come out, which will come out of this mixing tube, and we can as we have this abrasive water jet. Now I'm saying abrasive water jet. You can see at the end of the mixing tube we have the abrasive water jet. Okay, and the velocity of this abrasive water jet is very high. And with such a velocity, which is such a high velocity, then this abrasive water jet will strike the workpiece over there at the top surface of workpiece. Then kinetic energy of these abrasive particles is responsible for the removal of material from the workpiece. Okay, kinetic energy is responsible for removal of the material from the top surface of workpiece. Okay, and that kinetic energy of individual particles of the abrasive we can calculate using the simple formula, that is 1 half mu square. Okay, so here kinetic energy of abrasive water jet is responsible for the removal of the material. Okay, so once again I will repeat. Okay, once again I will repeat. Mixing of water jet and the stream of the 1 minute. Mixing of high pressure water and the stream of the abrasive, it will take place in the mixing chamber, mixing tube. Okay, as we can see in the diagram also. And rapid rise in the abrasive velocity occur in this mixing chamber, mixing tube, and after that rapid rise of velocity of abrasive will happen after when it will comes out of the port of abrasive, and abrasive particles coming out of from that pore, it will mix with this water jet. Okay, that is high pressure water. Okay, and then when this abrasive water jet, it will strike or impinge on that workpiece, then material removal will take place. Okay, that when abrasive water jet will hit or strike or it will impinge on the workpiece, on the work material, then that time momentum transfer will occur. Okay, kinetic energy means what? Then momentum, 1 half m square. You can say momentum transfer will occur, and that momentum one half m square. Okay, and due to that momentum transfer, material removal will start, and material removal will start. That means what? There will the action, and that action is what? Erosion. Here I have shown also. Okay, that material removal will happen due to the momentum transfer, and that momentum will get from the kinetic energy of abrasive water jet. Okay, so material removal here will occur due to the erosion, due to the shear, or due to erosion or shear or brittle fracture. Okay, so this momentum transfer will lead to material removal by which action? By erosion or by shear or brittle fracture. Okay, so this will depends upon the what are the properties of the workpiece. That means erosion असेल, the shear deformation असेल, किंवा brittle fracture. So that will depend that mode of material removal. It will depends upon the what are the properties of the workpiece material. Okay, if it is brittle material, then fracture may take place. If it is ductile material, workpiece material is ductile, then deformation happen, and erosion and shearing are going to take place in that case. Okay, and here pressure is normally 400 megapascal, and the jet speed or maximum jet speed that you can obtain is up to 900 meter per second. Okay, that is high velocity. And again here I want to mention that Okay, whatever will get a slot, no, that is a curve. Okay, it is called curve, and that cutting of that curve at or the cutting in the upper part of the curve, that will take place due to the mechanism, and that is called erosion action हा. ज्या स्लॉटच्या वरच्या साईडचा जो कटिंग होणार आहे ते कशामुळे होणार तर ड्यू टू इरोजन ऍक्शन, आणि कटिंग इन द लोअर पार्ट ऑफ द कर्व दॅट वुड टेक प्लेस ड्यू टू द डिफॉर्मेशन. ओके, कर्प म्हणजे एक प्रकारचा स्लॉट, आपण कटिंग केल्यानंतर स्लॉट पडतो ना त्याला म्हणायचं कर्प. आता त्या कर्पचं जे टॉप सरफेसचं मटेरियल रिमूव्ह होणार आहे, कटिंग होणार आहे, ते कशामुळे होणार आहे तर इरोजन, आणि बॉटम लोअर जी साईड असणार त्या स्लॉटचं किंवा कर्पची ती कशामुळे कट होणार आहे, कटिंग ऍक्शन होणार आहे, तर कशामुळे तर डिफॉर्मेशन. ओके, समजलं? अंडरस्टूड?
Yes, sir.
ओके, सिंपल सिंपल आहे का नाही? जे आपण ऍव्हरेज जेट मशीनला शिकलो आणि वॉटर जेट मशीनला सेमच आहे, फक्त काय त्यात थोडं मॉडिफिकेशन केलेलं त्याने, आणि त्याने हे नवं मशीन प्रोसेस डेव्हलप केलेली. ओके, अंडरस्टूड? ऑदर कॅन से यस नो. या ऑडिबल?
Yes, sir.
Yes, sir.
Now, may I proceed further?
Yes.
Okay. So before going for the setup of the element, here we have the point, that is the application. Okay, so totally technical application, not general. So this abrasive, what I think हे highlighter दिसते का तुम्हाला? नाही ना? Okay, so this abrasive water jet machining process, okay, it is used for metal. Please listen carefully. This abrasive water jet process is utilized, or it is used for the machining purpose for metal as well as non-metal. Okay, it is used for, or it is used to machine metals as well as the non-metals. Now, if you talk about the non-metals, then in non-metals you can go for the machining of ceramic, composite, or rocks, etc. And if you go for the metal, you can machine metals like copper, aluminum, tungsten carbide, lead, or even super alloys also can be cut using this abrasive water jet machining. Okay, I repeat, metals like copper, aluminum, tungsten carbide, lead, or even super alloys can be cut by using this process. Then again, this abrasive water jet process you can use for various kinds of operations. Now, which are the operations? So you can perform operations like drilling, cutting, deburring, etc. Okay, so it can cut any kind of material. Okay, this water jet, abrasive water jet machining process can cut any kind of materials with reasonably good edge quality, with reasonably good quality of cut, good edge quality as well as acceptable. Okay, now the important application of this abrasive water jet machining or cutting is that you can use the robot, and it can be used for the dismantling of nuclear power plant with the help of the robot. Okay, abrasive water jet machining cutting, you can use robot, and that robot you can use for the dismantling of nuclear power plant. Okay, with the help of that robot. So this is very important application of this abrasive water jet process, because in nuclear power plant human beings are not allowed or not permitted to go there because of the radiation effect. Correct? So abrasive water jet cutting is useful for such a kind of applications where you can control the cutting operation with the help of the robot at a remote place. Okay, understood? Understood?
Yes,
Yes,
sir.
sir.
Okay. Dismantling of nuclear power plant with the help of robot. For that purpose, this is important application of this abrasive water jet cutting machine. Okay. Abrasive water jet cutting or abrasive water jet machine both are same. Why they are given the name cutting? Because normally this process is used, okay, or mainly used for the cutting purpose. Now let us start the new point. अच्छा, कुठे गेलो? Let us start the new point, that is equipment used or the what with the setup. Before that, one thing is remain. Please draw this diagram. महत्वाचं राहिले. I will open diagram. Please draw this diagram. All of you, whether my diagram is visible?
Yes, sir.
Okay, please draw, because diagrams are very important for our you can able, you will be question
आवाज येत नाही सर. आवाज नाही येत आहे.
हॅलो,
हॅलो सर.
हा येतोय का आवाज? हॅलो,
हा, येतोय.
हा सर, आता यायला लागला.
ही डायग्राम एकदम सोपी आहे. सेम डायग्राम तुम्हाला विकेजनच्या बुक मध्ये पण भेटेल, फक्त ती डायग्राम ओल्ड आहे. ओके, सेमच आहे, फक्त ओल्ड आहे डायग्राम. Okay, I will show that also because I have of the muscle removal. I will show. दिसते ना डायग्राम झालंय डायग्राम मी मुद्दाम तुम्हाला
दिसते
हा मी मुद्दाम एजेएम साठी वॉटर जेट साठी आणि एडब्ल्यू साठी तिन्ही प्रोसेस मध्ये डायग्राम मुद्दाम मी तिन्ही वेगळ्या काढल्या कारण सांगतो तुम्ही पहिली जी एडब्ल्यूजीएम ची डायग्राम आहे ना ते जर तुम्ही मॉडिफाय केले तरी चालत्या फॉर वॉटर जेट मशीन किंवा एडब्ल्यू साठी तुम्हाला मी 3 ऑप्शन दिले ओके फॉर एक्झाम्पल युनिव्हर्सिटीमध्ये तुम्हाला तिन्हीपैकी एकच क्वेश्चन विचारला फॉर एक्झाम्पल वॉटर जेटच विचारलाय बरं का आणि तुम्हाला एडब्ल्यूची सॉरी ची फक्त डायग्राम लक्षात आहे तर ती जरी काढली तरी चालेल फक्त त्यात वॉटर जेट मशीन नुसार चेंजेस करायचे ओके दॅट्स इट ओके तुम्ही हे डायग्राम ऍव्हरेज पोर्ट जर मी क्लोज केला तर डायग्राम कसे होते वॉटरवर नाही तर म्हणजे वॉटर जेटचे होते आणि जर धरून चाला ऍव्हरेज जो पोर्ट दिलाय हाय प्रेशर वॉटरच्या ठिकाणी जर मी म्हणलं की हाय प्रेशराइज एअर then this diagram will become for the average jet machine okay in AJM we have you have used there is separate mixture chamber okay hooper okay and that vibratory motion we were giving for the that average but to convey or to explain the working principle or mechanism of material removal, we can use any diagram. Okay, but we have to go for the appropriate diagram. In textbook, they will give the different diagram. In reference book, also they are giving different diagram. Okay, and in the reference paper also, research paper. I am every time telling that about the research paper or the references because our subject is the advanced machining process. That means still research is going on. Okay, and we are getting the new result. So we should be with that. Okay. Once our college will start now, and once you will come to college physically, that time you please visit our central library, and in that we have the production technology one big book by HMT. Okay, same time Bangalore Research Center, Machining Center. Okay, they have gone for the different research, and from that research paper, okay, they published paper, and from that paper they have a written book. Okay, कारण आपल्याला माहित पाहिजे डायग्राम कुठून आपण घेतले म्हणून ते मी साईट त्याला म्हणतो SIT सॉरी CIT साईट म्हणतो त्याला रिसर्चच्या बाबतीत मध्ये साईट करायचं म्हणजे मी एखादं वाक्य जर लिहिलं माझं नाही स्वतःच दुसऱ्या पेपरमध्ये तर तिथं मी ते रेफरन्स लिहिणं गरजेचं आहे त्याला म्हणायचं सायटेशन आणि त्याचं मी सांगितलं की मी त्या एका रिसर्च पेपर मधले डायग्राम घेतलेले आणि त्याचं मी रेफरन्स खाली दिले मी एकदा खाली बॉटम लाईन दिसतं एकदम बारीक मध्ये लिहिलेले टाइम बिंग आम्ही साईट करायचं का सांगतोय आता धरून चाला आता ही माझा युट्यूबवर व्हिडिओ आहे बरोबर आहे आणि युट्यूबवर आता ज्याचं ही ओरिजिनल डायग्राम आहे त्याचं तर माझ्यावर केस करू शकता किंवा माझ्या पेपरमध्ये ही डायग्राम मी विदाउट साईट टाकली तर ते पेपर ते ज्यानं पब्लिश केला पेपर तो माझ्यावर केस करू शकतो का तर ह्यानं मला तो रिसर्च काय म्हणणार आहे मला न विचारता किंवा विदाउट माय परमिशन ही हॅज टेकन माय डायग्राम अँड ही हॅज रेफर्ड फॉर हिज पेपर ऑर his work. Okay, so that is a IPR or I can say copyright. Okay, so if you are taking any material in a diagram, okay, then you should cite that paper name. Okay, म्हणून मी या पीपीटी मध्ये खाली ते लिंक दिल्या किंवा ह्या लिंक मधून दिल्या किंवा माझ्या प्रत्येक लेक्चर मी एकदम लास्ट दाखवत असतो रेफरन्सेस. ओके, सो दॅट इज अ प्रोफेशनल वे. वी शुड गिव्ह द क्रेडिट टू दॅट ओनर. ओके, किंवा मी असं म्हणणार ना की मी डायग्राम काढले बाबा नो आणि काढा. ओके, आय डोंट हॅव दॅट राईट और अथॉरिटी ऑल्सो. ओके, वी शुड गिव्ह द क्रेडिट. ओके, तर रिसर्चर बघा, भले भले मोठे रिसर्चर सुद्धा सांगतात किंवा तुम्ही हे ऍडव्हान्स मशीन प्रोसेस बा विकेजनचं जर बुक बघितलं, ओके, सगळ्यात टॉपचा माणूस या फील्ड मधला, त्यांनी सुद्धा त्यांच्या बुकमध्ये काही ठिकाणी हे दिले रेफरन्सेस दिले किंवा मी हा पॅरेग्राफ ह्या बुक मधून किंवा ह्या रेफरन्स पेपर मधून घेतला किंवा वाचून आयतच घेतला नाही फक्त रेफर केलं. तर हे थोडं प्रोफेशनलिझम माहित असतं म्हणून तुम्हाला सांगितलं साईट करायचं वगैरे. कारण आता फॉर एक्झाम्पल हिअर आय विल टेक द नेम ऑफ मदन पाटील बिकॉज ही हॅज पब्लिश लास्ट सेमिस्टर वन पेपर. ओके, through that Wanker sir. So he knows that. Okay, in literary way, we have to give the citation or references. That is a professionalism. साईट करणं म्हणजे काय, ज्याचं वर्क आहे त्याला आपण त्याचं क्रेडिट दिलं पाहिजे. ओके, अदरवाईज कॉपीराईटचं केस होऊ शकते. बरं, ओके, झालं की मी वेगळंच सांगेल तुम्हाला. ओके, झाले, कम्प्लिटेड.
येस सर.
हा, बरं, आता आवाज येतोय का नाही ना? तुम्ही बडबड करतोय, तुम्हाला ऐकू?
हा, येतोय क्लिअर.
Okay. Okay. Now we'll go for the system, that setup or the machine used or which are the different components or elements of this system. Okay, we'll see. Now you can see here diagram. Okay, so here you can see we have the water treatment plant, or I in simple language I will tell, or I will say that is a reservoir for the water. Okay, then in that water treatment what will happen? Filtration of water, because we want pure water. No, if there will be contamination of the dust particle or other gradient, so they may affect the performance of our machine or system. So we need a filtration as well as the filter and dryer we need. So there in water treatment plant we can use that filter and dryer. Then to take that water from that reservoir we require the pump. Okay, so we have the pumping system. Okay, so that pumping system what he will that will do. So it will produce a high velocity water jet by pressurizing that water to as high as pressure more than 400 megapascal. Okay, how he will that pumping system will increase pressure with the help of intensifier, or it is also called booster. Okay, so intensifier is used, pump and intensifier, that is a pumping system. Okay, through which it will produce a high velocity water jet only. Okay, and by pressurizing the water up to 400 or more than 400 megapascal pressure with the help of intensifier. Okay, and to achieve or to acquire such a high pressure we need 75 HP motor may be required. 75 HP motor may be required. Okay, to achieve that much high pressure. Okay, and that water flow requirements it will be up to 3 GPM. Okay, are quite common. Okay, that statistic given by the Wikigen. Okay, 3 GPM, that is water flow rate. GPM for gram per minute. Okay, then that water it will come to that high pressure water jet. It will come to this nozzle part. Okay, and before that nozzle there is a mixer chamber. Okay, so in that mixing chamber there is a port of abrasive insertion. Okay, so there is an abrasive port. Okay, and on that port we have the abrasive hooper. Okay, for what purpose hooper is there? To give the abrasive particle. Okay, so through that hooper you can give the abrasive. Then in that mixing chamber mixture of high pressure water and this average particle will happen, and then through the mixing tube, mixer tube, you can give the that abrasive water jet mixture to through that nozzle. You can impinge, you can strike, you can hit on the workpiece by maintaining standard stand off distance or nozzle tip distance. Okay, so these are the components. Okay, here I will give in short which are the components or elements. Then first is the pumping system, which will include or which will contain pump, reservoir, and the intensifier. Then abrasive feed system. In that feed system, everything will come. Abrasive hooper or pour, okay, mixing chamber, everything. Then water jet. Okay, in detail also we'll continue this point in next lecture. And then we have the nozzle and catcher. Catcher is used to catch the that use the abrasive water jet particles. Okay, okay. Drainage, it is also called the catcher. Okay, so in detail this part I'm going to continue in the next lecture. So time being, please draw this diagram. Understood? Say yes or no.
Yes, sir.
Yes, sir.
Okay, so same part will continue in the next lecture because in detail I want to discuss this all part. Here only I have given the brief introduction. Okay, so one by one everything will continue. Please draw this diagram. Again, this diagram I have taken from one of the research paper. You can draw diagram that whatever we have drawn for the water jet machine, no? So same diagram you can draw for this AWGM. Just add the element of that abrasive feeder in that. If you search on that Google also, na, you will get diagrams, other diagrams also. But that colorful diagram and Sankey diagram, okay, that means arrow type. There is no meaning because, but for this diagram I can say because this is a technical diagram and this is I have taken from the one of the good research paper, report paper from Science Direct. Okay, so please draw this diagram, and by taking attendance, we'll stop for this lecture. Okay. Now, simultaneously, shall I go for the attendance?
Yes, sir.
Okay. Now, please listen carefully. फक्त एका स्टुडंटनं अनम्यूट करायचं आणि फक्त रोल नंबर सांगायचं. मी ओके किंवा नोटेड म्हणल्यानंतर पुढच्याने अनम्यूट करा बरं का. नाव फर्स्ट ऑफ ऑल ए डिव्हिजन TY बीटेक मेकॅनिकल ए डिव्हिजन प्रेझेंट रोल नंबर सांगा फक्त.
हॅलो सर.
हा सांगा.
रोल नंबर 50.
येस प्रणय डिस्ले. चलो
हाँ यस सर.
नेक्स्ट.
सर रोल नंबर 1515.
1515. येस नेक्स्ट.
Roll number
A division
46.
46 noted. Next.
38 सर.
38 noted. कोण 38 हे काय पाचकर कोणते चंद्रगुप्ता.
नाही
35
ओके 38 ओके. नेक्स्ट ओके नाव एवढं माहित नाही.
35.
35 noted. Next.
3.
A division 3. A division 3 roll number na.
Yes, sir.
Okay, noted. Next. ए डिव्हिजनचं कोण नाही का आता?
सर माधुरी प्रचंडराव A6.
6 ना?
हा.
ओके हा सांगायचं झालं. पुढं बोला. हे अभिनय गायकवाड. अभिनय
येस सर.
हे रेकॉर्डिंग बंद करा. काय प्रॉब्लेम आहे? अटेंडन्स काय गरज नाही त्यात.
हा.
हा अटेंडन्स